All right. So we are live here. Good evening, everyone. Hope all of you guys are doing great like that. Hi, I'm Candida. I am from REBASE by Recro. I'm part of the community team, and it's really great to have you guys here join us on a weekend. Hopefully, this session is going to be really insightful for all who have joined here. So our session today would be about master and micro front end. It would hopefully be a blueprint for you to associate in your career wise like that. And joining us here is Nihal. uh, so yeah, before we start with the session, I just want to give a small rundown about Rebase by Recro. As I mentioned, this webinar is hosted by Rebase by Recro. So I'm just going to share my screen. One second. Yeah. So Rebase by Recro, we are a developers company which is backed by Recro, and we are around 2,500 members here, which is growing each day. I think we are almost going to reach 3,000 if I'm not mistaken, and we have seen this much rate of growth in a year or so, and it's basically because of the backend which and support which we got from our amazing members and mentors in our community like that. And we are striving to actually make this community as one of India's best developer community. So it's a really good platform for all you guys who wants to connect with like-minded people. Uh, and so we do have a lot of mentors from giant tech companies like Uber, Microsoft, Google, and so on, like that, where these mentors do take up their time and come interact with our community members and do free mentorship sessions. This is a very much only community exclusive perk which we provide. And these mentorship sessions have been really helpful for our community members where they get to learn a lot of guidance and insights from these experienced people. Apart from this, we do also have a lot of offline meetups with our members, and like we are having a mentorship. We are having like a first ever offline mentorship happening tomorrow in Bangalore itself, where the community members and our mentors are going to interact. So we are very much excited for that. So yeah, these are some of the perks. There are more perks in joining our community where you can get to interact with, a lot of developers, get to learn a lot from each other, maybe get job referrals also from the community members. Just like you want to interact with your like-minded people, come join us. I'll be anyhow sharing the link to our community in the chat. Do feel free to come and check. I hope few of you guys are already part of our community. But then if you guys have not been part of our community, do come and check. We are very much active on Discord, so do come in and check in. So coming to our speaker for today, who is a highlight guest here, he's Nihal here. Nihal here has around 6 years experience and is a software engineer, senior software engineer in Apple. He have worked with other brands such as Walmart, Byju's as well. He's a IIT Jabalpur graduate, and he has experience in skills like JavaScript, React, and a lot more. I'll be sharing Nihal's LinkedIn link also here, so you can reach out to him and connect with him after the webinar. So Nihal, do you want to go add in something and introduce yourself?
Yeah, sure. Thanks, Candida, for introducing me. Hi, everyone. I am Nihal, and thanks for joining in on a long weekend. I hope you don't have to go anywhere else, or else I'll keep the session very short so that it doesn't take much of your time. And I hope you'll be able to get as much knowledge as possible related to micro frontend. Uh, yeah, so I think we can get started.
Yeah. So before we start again, I'll be like as I mentioned, I'll be sharing the link to our community. You can you can join in, as well as we'll be taking up questions also. So you can do drop in your questions in the chat. We'll be taking up these questions maybe in between the session if time permits us, or if not, we'll be having a Q&A session towards the end. So you can ask all your questions. Do ask a lot of questions. Be curious, ask questions, and yeah, Nihal will be very happy to take the questions for you guys. All right, Nihal, we can start the session.
Sure. I will share my screen. Uh, Canada, can you enable my screen share?
Pardon?
So actually, this saying host has disabled the screen. Can you enable it? Screen share.
Yeah, one second. Can you share now?
Yeah, I can.
Ah,
Okay. I hope everyone can see it. Uh, is it visible?
yeah, Nihal, it's you can go
Okay.
ahead.
Okay. Got it. So quickly, in the chat, I would say, how many of you know about micro frontends? If you can respond on chat.
Guys, you can put on your answers in the chat. Sorry, the chat was disabled. The chat is now enabled. You can, interact with Nihal on chat.
Okay. No problem. So let's talk about what is it actually. So micro frontend is basically an architecture style. Architecture style is it's not a technology or it's not any kind of a framework or something. It's basically a architecture style where you design or develop your applications in a certain way so that it's more scalable. It's basically divided into more modular parts, as well as it can be maintained separately. So it's like if you have heard of monolithic applications, and I think you have heard of microservice as well. So microservice is a concept which is coming from the backend side or server side of things, but same knowledge we are basically applying over here. Same fundamentals. Basically, you are dividing an application into multiple services, and all of them can be made scalable independently, and they basically communicate each other to form a same one single application. Similarly, in case of micro frontends also, we divide a front end app into multiple applications which can be developed, maintained, as well as tested individually, but all of them combined together to form a single application. That's like a basic concept of micro frontend. Now, taking for an example, like we have multiple kind of application. One is type 1, which has database backend and front end. It's called a monolithic applications. Then there's a type 2, so which has a database and backend which is separate, and then there is a front end which has been hosted separately. Then there is a third kind of application where we have different microservices which have their own databases and their own servers, and they are basically connecting to a, let's say, a single front end which has been developed by a single front end team. Now this basically goes beyond that. It's like kind of a type 4 kind of an architecture where all of these like database backend as well as front ends are divided into multiple services. So it can be either having all of the three, or it can be having either one of them. So let's say microservices might be we can have different microservices as well as different micro front end, or we can have a combined microservices along with micro front end of a specific service. uh, so let's take an example of Flipkart, right? Before that, let's say this has been widely adopted practice. So there are multiple large scale companies which are already doing it. Taking for an example of Flipkart, so let's say if you go and to flipkart.com, you will see uh, that it looks like a single application. It might be having a navigation bar, it might be having like you can see the categories over here like electronics, TVs, and then filters on the left side, and there is a product listings which is available in the right side. uh, if I tell you that this is not a single application, it's basically a combination of multiple applications. So how would you think? It doesn't look like that, so right? So but that's the case. So if you see over here, how it's divided is, I'm not fully sure, but this can be like navigation bar that's basically a part of a different application. Then there is a filter, and there's a category management service, which is basically handling this electronics, TV, and then whole drop down. This is basically part of a different application. And fourth one, sorry, it's the product listing page. So this is part of a fourth different application. By application, I mean different micro front end. I would say. So all of these are basically built and deployed separately to different URLs. So like the navigation might be deployed on a different URL. Then there is a filter application that might also be deployed on a different URL. Same talking about the product listing page. All of these applications get deployed to different URLs, and you can think of it as a different multiple application which are coming together. Okay, let's learn from the diagram. So let's say we have app 1 which has been hosted on a URL which is abc.com. Then we have app 2, this has been hosted on xyz.com. Now we have app 3, this is like a container application, you can say. So what happens is, uh, we this app 1 basically get embedded into app 3. Similar is the case for app 2. This is how micro frontend works. It's like multiple applications which are hosted differently are coming together to form a single application. It can be, we can even take basically a specific section of multiple applications to form a single application. So let's say app 1 has section 1. Now I don't want to take full application and want to embed it into app 3. Basically, I will take a small section of it and then I will embed it into app 3. So this is basically how the embedding of the micro frontend works. Similarly, let's say if it's not the case that if you want to, you can basically embed it into a single application only. Since this is a reusable kind of architecture, all of these applications are built in a reusable format. It can be embedded into multiple applications also. So like section 1 can be embedded into both app 3 and app 4. Like similar is the case for section 2 also. Similar is the case for other sections corresponding to all of these applications. It can be embedded into multiple such applications based on the use case. uh, Now, how to do it? Basically, how do we design this kind of architecture? So there are multiple ways of doing it. There's a framework called single SPA. It's like It's like a framework, a full-fledged framework, which basically helps you embed applications. Then there's a module federation. This is by Webpack. There's a plugin, and there's a way using web components as well as using React DOM. So we'll discuss three of these in today's webinar. Let's talk about single SPS. So this is basically a full-fledged framework. Like if you see like React, Vue, Angular. This framework basically provide you a full-fledged functionality of integrating multiple applications in a micro front-end way. So it's like it's basically a framework agnostic framework, as in like you can have one application in React, one in Vue, one in Angular, one in some other frameworks, and they all basically come together to form a single application. So uh, I can embed applications built on multiple such frameworks, and they basically come together and form one single application. So since this is a framework, this basically handles all the shared dependencies. It handles all the life cycle of all the elements, like how the components are getting mounted or unmounted. It's like React has a different life cycle, Vue has a different life cycle, Angular has a different one. So all of these are basically handled by the single SPA. Then there's a better inter-app communications which is being handled by this framework. It's not like all these applications are there, so it's not like those are static. They need to communicate to each other, right? So in terms of, if you want to form a single application, you need to communicate between multiple components as well as services. So all of these is basically handled by the all this single SPA framework. Now, apart from this, it also handles the routing and integrations. Uh, yeah, so it basically have a single SPA config file. This is like an example of a single SPA config file. Here, you basically have to specify how to register the application. Like you have to provide from where. If you see from here, like we have app2, and app2 will be basically downloaded from what kind of a URL, and what kind of route will help us in downloading the app2, or basically the app2 applications. And similar is the case for app1. You can basically go and explore this framework. This is like a having this has been widely used by multiple companies, and it's been adopted everywhere. And this is only con of this is a different framework, so you'll have to basically add a different dependency, and you will have to work along with the frameworks. So there might be some limitations related to that as well. Our next approach is basically module federation. So this is basically a Webpack plugin. So if you have heard of Webpack, it's a package bundler that basically provides a plugin called module federation. So basically, you'll have to configure the Webpack by specifying the entry files, and like it also handles the version matching. So if you have multiple applications, right, multiple micro frontends, there has to be different versions along with that, right? So you'll have to maintain different versions. So let's say if one of the sub application is having a version 1, it might not be the case that the application 2 will also be having version 1. It might be having a different version. So it depends on what is your version, and basically you'll this version mapping and all is basically handled by module federation, so that you don't have to face any issues while mapping multiple versions of the one micro frontend to another micro frontend. And this also allows multiple framework embedding like React, Vue, Angular. So I'll talk about how do we achieve micro frontend architecture using module federation. I'll show you a piece of code on how do we do it. So if you see over here, we have two applications over here. One is app1, one is app2. Now if you see the package file over here, we package.json, we have all the applications. If you have seen this, we are basically building it using Webpack, and then we are serving it using Webpack. If I show you the Webpack configuration of each of these, yeah, if I show you the Webpack configuration, so if you have seen this kind of structure, we have module.exports, and then we have multiple kind of style loader, SAS loader, which are already there. Then we basically add one more thing over here, which is the module federation plugin. Here we'll have to provide what kind of file name it would be. So it's like what file name you want to give to this specific application. Currently, what we are doing is we are basically uh, making this app one as a sub application which will get embedded to app 2. Now we have this file name. This is like a remote entry file you want to give. Think of it like an index.js. This is like a entry file where if let's say if I get the location of this file, you will I'll basically load this script and the component present over here, and then I will embed it into a different application. And I'll specify what kind of app I want to expose. As in exposes, I have given slash app. Slash app is basically, since I want to expose this app component, I have given this route over here, right? Now if I come to app2, right? So here is package.json. If you see, then there is yeah, it's also having a similar kind of package JSON. And then if you see webpack .config.js, here also it's like similar kind of an configurations I have given. But if you see the model federation over here, it has a different value. So it's taking remotes. Now what is remotes? Remotes basically is specifying what kind of application or what kind of component will be coming from a remote file or remote application. So since if you see the previous application over here, here I have given name as first app, file name as remote entry.js, exposes as the app, right? If I come to second one, I am based, since I'm consuming a component out of the first application, I've specified a remote over here. And apart from that, I've given a name that, okay, this component will be loaded as first app, and this is being hosted over here on this URL, localhost 8080 slash remote entry.js. Now, if you recall, remote entry is basically the one which we gave over here, like like a file name to it. So from here, we are exposing it, and in another application we are retrieving it. We are providing the URL, okay, go to this specific URL, load a component for me, and I'll basically load it in our application. Now uh, let's see how does it look like. Mm, yeah, so if you see over here, this is like one application, and then this is like another application, right? So one application, if you see, right, this is having, let's say, Go Shop. Now there's a search bar along with it, and then it's saying hello from app one, right? Now this is like, now what I want to do is I want to embed this specific section, like the navigation bar. If you see, right, this specific section along with the search bar, I want to embed it into app two. So this is basically app two, and I have given no, this was the component which I actually embedded. If you recall the webpack I showed you, this was the component which I actually took it from app one, and I embedded into app two. So I got it over here. And if you see the configuration over here again, if you see app.js, I have given for the first one, I have given a Go shop, then there's an input bar. This is like a navigation bar, and I am exposing this thing. Talking about app 2, if you see the app.js over here, I have got first app over here. Now, how did I got first app over here? First app is basically hosted somewhere else. It's basically hosted on localhost 8080, right? and my application is localhost 8081, right? It's a different application. If you talk about production, right, it's you can think of as a different URL altogether. uh, so if you see over here, right, because of this plugin, I have given that, okay, this component I have to load it from this specific URL. I am able to access that component inside this app.js. This is like on the React component. I'm able to access over here, like first app slash app. I want to load this component by lazy loading it. So this will basically load that component for me, and also I can add some of the props to it. So since this is like React component only, we can communicate between multiple such components using props. So let's say if I talk about giving a demo, now let's say if I search any kind of products, TV, let's say sofa, something, right? Now let's say if you see over here, right, I'm typing it in application one, and it's basically coming it in application two. So this is a different application, this is a different application, both of them are communicating with each other. So how is this happening? This is happening by props currently, because it's all out of React, and module federation is like a very simple framework agnostic plugin. So if you talk about only React, right, uh, you can directly use props to basically pass any data to that component. But let's say if you want to embed a different kind of application, let's say I want to embed a view application in a React app, then I'll have to do some another set of configurations which will pass the data from one application to another application. And if you see, it has to be pretty seamless, right? So similarly, now I can do what I can do whatever I want. So basically, I'm searching it over here. I want whatever data I'm getting, I'll pass that to this another application, and that will show the results according to that. So this is how the micro frontends communicate. If you say, right. Mm, okay, I'm just checking if there are any questions. Okay, right. So this is how the like the module federation approach works, where we are having where we are loading a remote component onto an application, and that would basically work that way. I have created a very simple React applications like app one and app two. You can see over here, and this is how they are working. This is how they are interacting with each other. Similarly, you can do for other applications also. Let's say, as I showed you for Flipkart, right? There was a filter or something which might be getting loaded from a different application, and there was the product listing which was getting loaded from a different application. Now, if you see one more thing, one more difference, if you see, right, there is one more component over here which says hello from app one. Now, this one doesn't get imported over here because I have not given, I have basically not exposed it on a URL. So I have only exposed this navigation bar. That is the reason I was able to embed it over here in a different application. Uh, Similar thing goes. So let's say if I want to use just this navigation search bar in multiple such applications, I can make it reusable as a different micro frontend, and I can use it in multiple different such applications, and that would be seamless. So it's like it's been hosted at one place. It's like as a that whole application, that whole navigation as a service I have hosted in a URL, and basically I'm rendering it everywhere. So you can think of it like how iframe works, right? But iframe is a different thing actually. It doesn't like load it as a single page application. It's like loading an app application within an application. It's like having its own DOM tree and all those things. But this is a different approach we are following. uh, Moving ahead, there is one more thing, like if you are using hardcore React, right, you can achieve this micro-frontend style of architecture with a simple approach using React DOMs. So if you know about React DOMs, they are master in basically mounting and unmounting components and applications. So like if you know about React DOM, it has render and all those methods, right? And then basically whatever application you want to mount, basically use React DOM only. It has a different virtual DOM over altogether, right? So if you're using React altogether, you can use React DOM to mine like basically mount different micro frontends. So it's basically specific to React only, and data passing is also very easy using props. So now if you talk about another application, which I'll show you. Let's take a cheap copy of Flipkart, right? So it's like we have named it as Go Shop. I have given browse so far surprised me about, right? Now there's a search bar and there is a product listing page over here, right? You can see multiple products. Please don't mind the CSS. It's just for the demo purpose, right? So now, how many of you think, like, what all things are different applications over here? Like, how many applications are interacting over here? So I would say there are around, it's not one application, but yeah, it's correct. It's around three applications which are basically interacting. And not just this page, there are multiple other page as well. So if I click on this, there's a different page it goes to. And then let's say if I come back to here, it says browse so far again. We have all of these listings which are available right now. Let's see how we have achieved it. So I would say this Go Shop is one application. This product listing, this is basically another application. And if you click on this, right, this is basically another application. So if I show you, sorry, yeah, if you see over here, right, product order, this is like one application. And yeah, if you see, right, this is like altogether product listings, right? And you don't see any navigation bar over here, you don't see any category browsing over here. This is like one such application. And so it's hosted on localhost 3001. And there is like this localhost 3002 which is hosting the product detail page. And then there is this localhost 3000 which is the main application where we are embedding the 3001 and 3002 port application. uh, Now I'll show you how do we do it in using React DOM. So let's go to this container application. Right now, what is this container application? This is basically having that whole navigation bar, and this is embedding the other applications. Right now, we have novel package JSON. You have seen this in every React app. We have just one more additional thing, which is like React app rewired. This is like a library which will help us in segregating the shared dependencies, right? I'll talk about managing the shared dependencies in the coming slides. Now but yeah, everything else is like similar to like how we create an application using create React app, right? Now if you see the index.js file, right, we have already used React DOM.render. We have an app over here, and we are basically using an unregistered like service socket here. Then if you see inside the app, let's dive in into the app, right? Now what is the app having? If you come to render, we are having the browse router. I think you have already seen this. We have the app header. This is the app header component, which is basically having all the navigation bar which I showed you earlier, right? Then there is a router, React router, and that is, if you see over here, it's loading multiple components, loading browse, product, random, and about, let's say, right? Now how is it loading browse, right? Browse is not even here in this application. If you see, right, there is no browse component, right? um, it's all different. It's having app header and nothing is there, right? Browse. So if you come over here, you see that browse is basically been like I have given a different mic. It's basically wrapping. It's wrapping around a different component. So I've wrapped it around a different component. If you see, we have micro front end component over here, which I am passing the history and host and the name of it. And that is basically creating a new component and giving us a browse component, right? Now, what does this micro front end component does? Let's see. Okay, right. So we have this micro front end component. What we are doing is it's like a normal React component we have created, right? But apart from that, we have added some additional configurations over here, which will make this micro front-end component scalable to all to importing all such other components you want to import in the application. So let's say micro front-end, if you see, right, we have the life cycles like component did mount. I have used React 16 over here basically to show you around the life cycles, right? So it's like we have component in mount, we have component will unmount, and then there's a render micro front end, and there's a normal render function as well, right? Now, if you see over here, we have a main specific HTML element, which where we are mounting all of these components, right? So, and if you see, we have in component did mount, we are loading all the render component. We are basically providing the name of the component which has been coming from props and a script ID to it. And this is basically loading a different kind of script over here. And this is we are having component will unmount, where we are using window of unmount. Then we are providing a name. It's like a generic function we have created. So this is basically used for mounting and unmounting the component. So it's like on will unmount, it will basically call the specific components will unmount, and on render micro frontend, this will basically render that specific micro frontend, right? Now, what is this window unmount? What is this dynamic naming and all? What is the dynamic function doing, right? You might be wondering that, right? Now, let's say if we go over here, right, let's take for an example of a browse component, right? Browse, it's been let's say if you come to app.js, or let's talk about index.js, right? Now, if you will see what I've written over here. I've written two components, sorry, two functions, I would say. It's like window.render browse, and there is window.unmount browse, right? This is basically I've assigned to window object. Now, what I'm doing inside that, I'm basically calling react dom.render, and that would basically render whatever component I am providing, right? Whatever app or something, right? So here we have in this browse application, I have entry point as app, right? So I'm providing this, I'm rendering over here, and then in the unmount browse, I'm using this react down dot unmount component at node. And if you see render browse and unmount browse, right? And if you see over here, unmount name and then name hyphen container, what is this? This is basically, let's say we talk about browse, it's like this is unmount browse and this is render browse, right? So I'm using two of the React DOMs methods to mount and unmount the components which are being hosted remotely, right? I have given the URL to it, and I'll basically load the script over here. Like if you see, uh, we'll basically load the script over here, and then we'll basically render the micro frontend. Now, what will happen in render micro frontend is once that specific script is loaded from on that specific URL. Now, in this case, this browser is being hosted in localhost 3000. So I'll use the URL as localhost 3000, and then it will fetch that main.js script from there, and then it will basically do the call the render micro frontend. And in case I want to unmount it, I will call the unmount component, right? So specific components I have specified over here, right? Similarly, if in case of other components also, you can see uh, we have product order. This is basically the product detail page. And if you see the index.js file, this is also having like similar kind of a structure, where we have a render product and unmount product functions already present over here, which is again using this React DOMs methods to mount and unmount the components, right? And I have, what is the app, right? And this app is basically this product detail page you are seeing over here, right? Now I'm basically, this is like the application container ID or something which is coming. And so now over here we have this browse, we have render product detail, right? I think two of these components are basically getting rendered on the same application. And since these are React component, data passing is happening through props, right? Now you might be wondering what happens if this is not a React component, or in other cases, right? There are multiple ways of passing data between these applications, right? I can I can show you. I'll show you in the coming slides. So now let's try to play with this, right? If I try, let's say adding wake up, right? This, all of this search is working fine. Now, if I go to surprise me, right? This will give me some random product from, it will basically load that browse component from, or I would say the product detail component from somewhere else, and it will give me, based on the routing, it will give me the component. Similar things for normal browsing as well, right? Now, let's talk about how will the data passing works if we are not using React, right? So we can use multiple things like this event bus. So event bus is like, you'll have to create a event class where you'll have to add a publisher and subscriber events. And maybe you can trigger an event from one place, and then you can subscribe to those events in multiple micro frontends. Similarly, you can do it using custom events also, like you can you can trigger custom events from one application, and basically you can add a event listener or some, or handler basically on another application to get the events. Talking about shared state management, right? Now you might be working with Redux and all. These are basically stores. uh, so in what happens about for the store in case of micro frontends, right? So all the micro frontends can have different stores, or they can have a single store of a container, right? Anything is possible basically. So the micro frontend which might be having their own Redux store, that might be communicating with their own Redux store. And let's say if you want to share that store between or basically the store data between the components, you can use multiple things, like you can basically pass using custom events. You can use local storage. So generally we are persisting the store, right? We are persisting, as in you want to save it to local storage. Whatever data you are getting, you want to store it to local storage for caching purposes, right? uh, how now basically you can use local storage for communicating between multiple Redux store also, like app one will save some data into that local storage, then that can be accessible to app 2. Similar thing for different, like app 3 as well, right? And now app 3 is saving something that can be used by app 1 and app 2, right? So, and the other thing is props which has been already been there. So this, like, these are multiple ways where you can communicate between the between different micro frontends. And this can be also persisted using local storage or any other such storages, right? Now coming to testing, right? So how is the unit, like how do we test all of these components? So I mean, if you talk about unit testing, you'll have to test all of these individual components. So as in, like, App 1 will be tested separately. That will have a different set of test cases. Similar thing is for app 2 and app 3. So all of these will be having their own unit test cases, and this makes it easier actually to check basically if that whole on, like, let's say if you want to debug something, right? You can try running unit test cases or something, and let's say you some let's say if app 1 got upgraded to version 3 or something, right? And let's say, and you want to run some of the unit tests, right? You can individually test that specific application, and you will not need to run the test cases across all the application, right? So specific module or specific applications can be tested independently. And talking about integration testing, I mean, we'll have to verify interactions between micro frontend. Obviously, that will happen for sure. But how do we do integration testing is like we generally have frameworks like Selenium and all. So generally, automation tests are there for doing integration testing between all of these different components. So since this will be loaded within a single application as an HTML or JavaScript HTML web page, it would basically be tested by using this framework seamlessly. Like end-to-end testing, like we'll have to validate the complete user journey across micro frontend, and also we'll have to verify multiple contracts and all which are being between different micro frontend. By contract I means the API contracts, or APIs which are being communicated with the multiple application. Similarly, if we talk about authentication, right? How do authentication work? So authentication will also work in a similar fashion where let's say if you have cookie based authentication or something, right? So one application will save a cookie, and other applications, since they are embedding, ultimately they are like components and all which are being embedded in a specific application only, right? So ultimately the URL gets changed to that only, and this they'll be able to access those cookies. And plus you can share some of the data using the data communication, like how we mentioned, like using custom events or event buses. We can share the data internally. Now talking about like performance optimization, like how do we optimize this application? So it's like three different applications, right, that might be having their own React, they might be having their own framework like Vue, Angular, or let's say let's take for an example React only, right? So all three applications might be having a React file which gets embedded over there. They might be having let's say same bootstrap or same material or whatever tailwind css, whatever dependencies, let's say external dependencies you are using, right? They might be having their different bundle of it. So ultimately whenever you are deploying an application, right, that basically deployed as a bundle, right? Now that bundle will have React, it will have other shared dependencies, right, which you are using, right? So talking about, let's say if we bring all these applications together, so all of these will come with their own versions of React, their own version of Bootstrap, and all of these together, right? So what we have to do over here is we don't want this additional overhead over here. So we have to manage the shared dependencies in a way that uh, it can be so that one application's React can be used by another application also. So you don't need to bundle also, like along with the application component, all other things doesn't need to come as a bundle file inside this application whenever it gets embedded, or else it will bloat up things, or it will do some unnecessary things which you don't expect to do it, right? Then you so it's like you have to carefully handle the shared dependencies. You have to do it efficiently. Like if you talk about my applications which I have built, right? So talking about this container application, I have if you see the index.html, I have given the like style sheet over here. This is fine, but if you see over here, like we have script, right? So I'm using React and React DOM. So I have basically used this single script over here. This has been shared by all of the three applications. So when the applications are hosted independently, right, whenever they are used independently, right, they will be loading this react their own react, they will be loading their own react dom. But whenever it's been embedded to a different application, it doesn't use that their own version. They will basically use this external one which we are already given in the container app, right? So this is how it works. So you'll have to specify react or basically the any external dependencies, any shared dependencies you'll have to specify. And they will have you'll have to specify the external dependencies that will help you in optimizing the performance, right? Or it will not bring in additional dependency along with it. You'll have to do module on demand loading, as in like this is basically simply calling it as lazy loading. So uh, whenever you want to load a module based on the router, based on anything you want to do, right, you will have to basically do an on demand loading. That would definitely increase the optimization, it would improve the optimization. And we'll have efficient data management and store. So we'll have to do a lot of data management and storage handling you'll have to maintain over here, so that we have to do it very efficiently, because there's like multiple applications are communicating with each other, and there might be a possible chance that some of the data or might be here and there might be getting uh, lost or something, or there might be a lot of bloat ups or something if you are storing a redundant data, right? So you'll have to manage that efficiently. Now coming to use cases, right? Why should you use micro frontend, or where should you use micro frontend? Okay, I'm happy with my monolithic code, I don't want to use micro frontend. Okay, don't use it. No, but there are certain scenarios where you want to use it, right? What are those? If you talk about, let's say, large and complex applications where multiple services are there, multiple use cases are there, which are being independently, if there are different teams which are independently handling it, I think that's the best possible scenario where you want to use micro frontends. So I took an example of Flipkart, if you recall, right? E-commerce is a very diverse a set of application that it's very complex application. A lot of things goes underlying that, right? So we would want to use micro-fronted architecture over there, because there might be there might be a search service, there might be a category management service, there might be a product listing or checkout service might be different, order management service might be different, and all of these might be will be handled by a team of, let's say, 20 to 25 people minimum. So, and they might be having their own release cycles, they might be having their own uh, basically workflows, or they might be having their own set of requirements and all, right? So in that cases, it's best to use micro frontends, because in that case you can do whatever you want with your own specific module, and that module you can build it independently, you can deploy it independently, you can test it independently, basically maintain it independently. And ultimately that will be forming, all of these small modules will be forming a single application only. So this basically helps in avoiding a lot of complexity, and yeah, it helps in improving the whole workflow of the organization, right? But you'll have to see how scalable your teams are. It's not like that okay, it's a complex application, but let's say if you have a limited number of resources or people available, you don't want to go for micro frontend approach, because then you'll have to maintain it differently. So it depends on team scalability also. Now another use case is like common reusable module. So let's say if you want to build a common reusable module, uh, which I want to deploy it at one place, and basically use it across multiple applications, then yeah, micro frontend is a approach you can go with. Now you will say, why don't we create a library and then use that library in multiple applications? Agree with you. You can create a library. You can basically host it on npm or wherever you want. You can import that library into your applications and then use it. But uh, library will not be able to do multiple things. Let's say if you want to call any APIs or something, generally it's not recommended to use a library. Let's say if you want to use that library as an independent application, it's not possible with that, right? You'll have to anyway host it somewhere. So there are some set of limitations. It comes with creating an npm library. So where microfrontend comes into picture, they can help you in hosting your application, making your component reusable. Let's say talking about this search application only, right? Let's say I am making a repository and I am having a, search bar over there, and that might be having some product listing. Now that product listing and search bar, I want to use it in multiple places. I'll basically create a micro frontend out of it. I'll host it, and then it can be reused across different applications wherever I want. So yeah, a common reusable module would be a definite use case. um, you can use this approach if you want to have tech diversity in your application. So let's say you are building an application, you already have a large running application which has been already been very complex, and you come across a use case where this specific framework or something which you are using doesn't suit your requirement, right? You want to build that functionality on a different framework. Maybe uh, there might be many use cases or something like which you might have thought that okay, maybe the bundle size is huge or something, we don't want to use that specific framework for that. So you can do a partial development into, let's say, any other framework, and then using this approach you can host that application over there, and then embed it over in your existing application uh, as a single application. So that would work seamlessly. If you want to do some if you are migrating your code to something else, I would not recommend you for fully migrating it. But let's say if you are breaking things breaking your application into multiple modules, and you want to create a different module using a different framework, so this approach would definitely work for you. You can create it in a different framework and then embed that into your application, right? If you have independent release cycles, right? Let's say product team is having a different release cycle, search team is having a different release cycle, and the category team is having a different release cycle. All of these, if you are multiple teams which are working in a cross collaboration to form a single product, right? And you have a different release cycles, you can definitely go with this approach, so that your different module can be having their own independent release cycles. You can do whatever innovation or something you want with this product with your own specific set of module, and then that can be maintained independently and can be released independently also. So because yeah, if you that's one good point. If you talk about, right, micro frontend, since they are deployed and hosted differently, right, they can be having a different release cycle, because all of these micro frontends will be treated as a different applications only. So if we talk about an application, obviously there will be a different release cycle for all the applications to be hosted, right? Talking from development to deployment to testing to everything. So all of these you can basically sorry, hold on. Yeah. So all of the components you can all of the components or applications, you can test it independently, and you can host it independently. So there's a different release cycle. So it's like a vice versa scenario also. In case of if you are going with this approach, then definitely you will have to follow independent release cycles, or maybe you can club the release cycles also based on your team scalability, how much your team can scale into, right? uh, Then yeah, as I've already mentioned, update sections of app without changing other modules, and then build independent modules. So what do we mean by build independent modules? As in, like, let's say, you might have seen some of these scenarios earlier, right? So in case of, if you go to flipkart.com or Amazon, any other website, right? um, if you are searching anything, right, and it suddenly says, okay, something went wrong, right? But if you go to another URL, let's say category or something, that is working, right? How does this happen? So it's like one service might be down because of something, but other service might be active, right? So this has been already been achieved by microservices, like, since, uh, let's say if one service goes down, other service is still working. So obviously, it's like it doesn't indicate that your whole application is down. It's like specific section of application might not be working, right? Similar is the case for micro front end also. Let's say if one module or something is not working, it goes down, then other one might still be active, right? So this is the benefit of deploying it independently, right? So now I'm browsing something, anything which goes down doesn't mean that my whole application is down. That specific thing might not work. You can easily go, and you'll know basically that, okay, this specific section of the application is not working. So this service might be down or something. This micro frontend might be down. So you can go ahead and do the necessary uh, uh, firework, basically necessary testing or something to make it up, or necessary tasks to make it up. Okay, so these are the specific use cases where you can use micro frontends. Talking about the pros, so yeah, it definitely improves the developer experience. It enhances the reusability. It's like easy to maintain and upgrade. So each of the modules and all can be independently upgraded. Like, if anyone is a Vue developer over here, you might know that there was uh, a recent requirement that Vue 2 to Vue 3 migration made has to be upgraded, because Vue 2 would have been end of the life, I think, by December 2023. So if you would have been using micro frontend, you can individually upgrade some of the modules to Vue 3, because that process was not seamless. So unlike React, Vue 2 was deprecating multiple things, and Vue 2 was deprecating multiple things, and a lot of things were breaking in the process of migration from Vue 2 to Vue 3. And that is the reason a lot of people faced different issues, that they migrated when they migrated the whole app, because it took much of their time, and all of their business time as well, because there are business requirements also which comes up, right? So if you have an application in micro frontend, it would basically help in, let's say, migrating one of the module to let's say Vue 3, and then keeping the rest of the application alive, and not touching all of this, and it can be tested independently, doesn't break things for the whole application. Like, smaller things can be upgraded and tested. Similar, if you want to do for team automate, like, let's say if you want to do some kind of innovations in terms of uh, if you remember, like, Elon Musk, when he took over Twitter, he changed the color of multiple blue ticks and all. He changed the color of the tweet button. He did multiple all of those things, right? Why did the other or he changed multiple such other functionalities also? Why did the whole application didn't go down? Or because he was upgrading to that specific module or the specific micro front end of that application, and then was basically deploying it. So only that specific version was getting updated, specific module was getting updated, and you can do any kind of innovations or stuff you want to do independently for a specific module, right? uh, it has faster development cycle. So since you don't have to in some cases, as in, like, if you don't have a, like, tightly coupled dependency on any other my kind of a micro front end, an individual micro front end can have, like, faster development cycles where they can quickly reform their requirements, develop, work on it, and test it, and then quickly release it. They don't have to wait on the whole application to go through a quarterly or yearly release cycles whenever it goes. They can do individual module releases whenever they want. It has basically, it also, like, using micro frontend would also help you in preventing fault isolation, as like any fault or something which might be happening. I already given an example that, let's say one section goes down, other application, or like the other micro frontend might still be up. So it basically isolates the whole fault, or basically error behavior, or any such kind of event which has been happening to a specific module. It doesn't touch the other application if it's not tightly coupled. Now with pros, it comes up with cons as well. So uh, obviously it increases complexity, because it's like you are having multiple different applications. Lot of data might be there. In case of huge application, lot of data flow might be there, which is been communicating by, let's say, multiple applications or multiple micro frontends are communicating with each other. There might be different a huge amount of data which is being communicated between the components. So it definitely increases the complexity. There's a communication overhead. You'll have to do a lot of data management over there. So there's obviously a performance overhead, since you are loading the multiple application which has been deployed into different instances. It will definitely trigger your performance. So you'll have to take care of the optimization. You'll have to do a lot of performance optimization. I think I already shared that with you in the previous slides, that performance, like how do we do the performance optimizations. There are many more things which can you can read about. Then there would be consistent UI UX challenges which will appear, like any kind of user experience which has been changing. There would be a challenge to it, like because it has to be adapt with what other section of the application, or basically the other micro frontends might be having. So you cannot simply change the user experience of the user, because in that case other applications or the other micro frontends will also have to update their UX, user experience. Or I would say, let's say you are adding a different UI design altogether. It won't work that way. You cannot upgrade the UX design in that way, right? There will be challenges with versioning and compatibility. So you'll have to efficiently handle it, because there might be cases where you are loading a micro front end application, you're loading multiple applications, and then in that case, previous one of the application might be using a previous version. It doesn't get upgraded to the newer one, right? So that challenge is still there. So you'll have to efficiently manage that. There are costs which come along with it. So this happens along even with the microservices applications, right? So in case of monolithic, you'll have to deploy it one place, and then there might be different instances and all where you deploy it, right? But in case of micro frontend, you'll have to deploy multiple modules into multiple such instances into multiple locations, right? So there is definitely an overhead cost which comes with it. So if you are ready to bear with it, I think this would be a definitely a good architecture design to follow. So yeah, so there are additional costs, and you have to find a way to optimize those costs. So costs are there, I mean, in terms of deployment and all, as well as in terms of data management and all, right? But it also somehow helps in making the application scalable, since because it's already fault isolation is happening, like one goes down, so another won't be affected. This will give the user experience seamless. So let's say one flow is working but another is not working, it doesn't affect the user much, rather than the whole application going down. So there are costs associated with it, but there are benefits with it also. So security management overhead is always there. So you, since there is a lot of data passing, data communication, to how to securely manage those data is also a very overhead on us. So let's say uh, if you are passing one of the data into another kind of app micro front end, and that is basically doing an API call, right? There has to be a CSRF token or any such things which goes along with it. So you'll have to efficiently manage the security of that application. So yeah, these are the cons. Yeah, I think so. That's all from my side. Yeah.
Uh, and that was a really great session. Maybe we'll take up few questions. So there's some questions that everyone have put forward in the chat like that. Let's do a little bit of Q&A session. All right. So see. So Rajesh is asking, like, please let me know when to choose micro front end at what scenarios.
Uh, yeah. So I think I've already answered few of these questions. So
Okay, okay,
the use cases I've already shared. What are the use cases of using micro front end?
okay. Let me check again. Few more there. Okay, there's one question. Is it easy to implement the React DOM method of front end than modular federation method?
Uh, I mean, yeah, I would say definitely it's easy. Like it's the simplest approach. If you are using React DOM, then yeah, you don't have to basically eject out of it, like using, so with, if you're using webpack module federation, right, you'll have to eject the react application. So if you don't want that ejection, you can basically use react dom, or else you'll have to eject it and then add those plugins and then add those configurations along with it. So it's not, I would say it's not easy, but yeah, if you don't want to eject or something, react dom would definitely work, since it already comes with the package or something which you are having. And it depends on the use case also. So let's say if you don't want to use like webpack or something for a specific micro front end, right, react dom always anyways you are using always. So any react application, react dom already comes up with it. So yeah, you can use react dom in that case.
Okay. There's another question. When we talk about micro front end deployment, how can we deploy? Do we first combine them and then deploy, or deploy all apps individually?
So in case of micro frontend, yeah, the core is you deploy the apps individually. So it's like all of these applications will be hosted into different URLs, right? So it's like one application might be hosted to some a different URL, like xabc.com. Another might be using like xyz.com. So all of these are deployed individually, independently, and similar to that, the deployment flow or the CI/CD flow is also different for all of these applications. So that is the reason. That is the main thing. Main, I would say, architecture pattern of the micro frontend. So all of these are deployed differently, and then we basically bring them all together into a single URL.
Okay. So there's a lot of questions actually coming in.
Yeah.
Okay. Do you feel that handling single sign outs with those front ends easy to achieve?
Mm, sorry, I didn't got single.
Do you feel that handling single sign outs with those front end easy to achieve?
Okay, handling single sign out with those single sign out, as in you are, I think you're already talking about authorization. So yeah, I mean, it's definitely not easy to achieve, but yeah, there are challenges which comes up with it. So if you are having a data management proper, I think a single sign out, obviously there will be a single sign out. So if you see multiple application hosted over there, right, they might be having like how do they manage their authentication? They are having their single authentication, right? They log in at one place, they are sharing the data across whatever the cookie based or whatever kind of authentication they are using. They expire it on singles on a sign out, right? So if you do a sign out, I think uh, yeah, it's complicated, but yeah, it's achievable with micro frontends. So there would be a single sign out, but the data flow you'll have to manage.
Yeah. Maybe we can take two more questions. Is that okay? How can we make sure React not downloading again when we are downloading sub applications and container applications? Do we need to add separate configurations?
Yeah, you'll definitely need to add different configurations for that. Let like if I showed you, I think I added React app wired library which was there. So that was helping me in adding React as an external dependency. So let's say whenever I was using that application as an individual application, in that case it was using my own React, that application's own React. But when it was getting embedded to a different file, right, in that case it was using that applications the embedded applications React file. So yeah, this is how it gets managed.
Okay, last question for the evening. Do you have any repo with micro frontends with authentication and authorization and CI/CD for getting some reference?
You're talking about GitHub repo?
Yeah, I think so. Sahil has asked.
I don't. Okay, I don't have it actually handy, so I don't have this content uploaded on GitHub. But I'll try to add it to my GitHub account and I'll share it across. Yeah.
Okay. So yeah, that's it. I think we do have a lot of questions, but then maybe we can do another webinar also on the same topic like that. So all these questions can be answered. Thank you, Nihal, for joining us again and giving us a very insightful session. I'm pretty sure seeing the amount of responses which we are getting, it was a learning for all of these who have joined like that. So thank you so much for spending your evening and joining with us like that. If you have any resources from this webinar that you would like to share with me, you can just like to the people, you can just share it with me. Once you guys come to the community, I'll be sharing it in the community. So who all have not yet been part of Rebase, do join our in our Discord, and you'll be getting all the recordings and the resources which Nihal will be sharing over there. All right, Nehal. Do you want to say anything before we end the session?
Yeah, thank you so much, all of you, for joining the session. I think I hope everyone would have learned something from this. This was just a start for the micro frontends. I think it's you can explore it on your own. So I have just given you a head start on how things work behind the scenes and what all things you can actually learn to implement micro frontends and all. But yeah, the ultimate learning is on you. So I have also given use cases. I'll do share the keynote with all of you so that you can uh, uh, you'll have it handy on like all the resources which are there. So yeah, thank you so much.
All right. I also shared a feedback form in the chat, so please take a little time and do fill the form so we can
Yeah,
make the next session again better. Also, your feedbacks really matter to us. And yeah, you can find the community link in the chat. Do join our community. Come to Rebase, explore Rebase. If you want to meet people who wants to grow, like we have a growing community with us, so we would like new faces also to be part of the community. All
yeah.
right. So hope
So
everyone has a good weekend. Thank you so much.
thank you.
Bye, Nihal. Thank you very much.
Thank you.